Hello, my name is Rama Murthy. My roll number is 213. I got the problem number 7, which is shift reduce parser for grammar h derives 0s0, 1s1 and 2. Shift reduce parser is a bottom-up parser that it uses a stack, input buffer, and displays action performed. I'll explain with the help of an example. Let's say the input string for to check for this grammar is 020. We have to append a dollar to the input string. Um, so what shift reduce parser does is it checks the top characters of the stack to find any right handles of the productions. If it finds the right handle, it replaces it with the LHS of that production. Say in this step, it found the right handle 2 of this production. So the replacement is called reducing. It reduces it to S. That is, it replaces this 2 with S. Similarly, in this step, it found 0s0, so it will reduce it to just S. That is, pop these 3 characters and push an S. If it doesn't find any right handles of the given grammar of the given productions, then it will check the current character of the input buffer. If the current character is anything other than dollar, then it will shift that current character to the top of the test. That is, it will push it to the top of the stack. If none of the productions right handles are found and the current input character is dollar, if it's dollar, it means the input string is empty, then it's an invalid string. It's an invalid string for that grammar. It's a valid string. It's accepted if the this input string is empty. That is, it only buffer contains just dollar, and the stack contains the start symbol, the starting variable, which is s. Then it's a valid string. Okay. Uh, the program, we wrote a C program to implement this. Of course, a string stack and an input string to store these values, and input pointer to point at the current character of the input buffer. We initialize the top to -1. We require push functions, pop function and display function to implement the stack. The push function just pushes the given argument character to the top of the stack and increments first increments the top. Pop will no need to display anything here, so just reduce. This is the top, and since we are dealing with the strings, the last character of the string must be a null character, so it will place the null characters to the top. Display will in this display function, we are just displaying the stack and buffer. Action will be displayed in the loop only. So coming to the main function, we first display the given grammar and ask for an input string. We initialized with the stack with a dollar, and the input buffer already has. We ask the user only to input to concatenate to append a dollar to the input. Now, suppose if the user enters an empty string, that is a dollar, then it's a null input. That is, if the top of the stack is dollar and current input character is dollar, it's a null input. It's like epsilon. We can if the epsilon is accepted, we can accept it. Now, other than this, we run a infinite while loop. The breakpoints of this while loop are either when the string is accepted, that is valid, or if it's invalid. Only then these are the breakpoints. It is valid. A valid accepting state will be when the stack contains dollar and the starting symbol, which is for a s. We check that by top character is s and the top -1 is dollar, and input buffer is empty. Then it's a valid. It's invalid when none of the productions match and the input is already empty. Then it's an invalid state. An example of invalid state is say $00. Here the 00 doesn't match to any of the RHS, and the input buffer is just dollar. So it's an invalid state. Let's go back in order. Okay. So apart from these two conditions, it will first check the top of the stack. If the stack is empty, I mean none of the productions are yet started, then it will just directly shift the current input character. So when the stack is still empty, it will directly shift the current input character. In case if the stack, then okay, that is this condition. If the stack now other than that, we have to check for the three of the input are handles. These three handles each has a if block. These can be interchanged in any order. Let's first check for input handles 2. So the top of the stack, we'll check if the top of the stack is 2. While checking the handles, we don't have to again check the input buffer. We only have to check the check the stack. So if the top of the stack is 2, then of course display for our output display the stack and buffer. This contains just one character, so pop once and push S. S is the LHS of this production, and display action S-2. Else if the top of the stack is 0S0. These can be in any order, these three if blocks. So if it's a 0S0 is match, then display these two, and we have to pop 3 characters and then push an S, which is the left side of this production, and display action. Similarly, if it's a 1S1, even then push 3 characters and trees. If the top of the stack doesn't match any of these conditions, it means it didn't match any of the right handles. Then check the input buffer. We checked it in reverse here. If the input buffer is already $, that is not none of the handles matched and input is empty, then it's an invalid string and we break here. Else we push the current character to the top of the stack, which is display. Even that's a shift action. Say here it didn't match anything 0S, so we display it and we shift. Shifting is we push the current character and move the input pointer ahead. So after performing the while loop, all steps will either end with the valid or invalid step, and it will break. That's it.